All right, guys, here we go with my next video for you. This is for your problem number 7 for the week of April 20th through May 1st for your Eureka Module 4 assessment problems. This is my sample problem 7. All right, so here we go. You see I have a graph drawn here. It looks similar to the graph that you have. I have two lines there that are intersecting at a point right here. This is my line 1, this is my line 2. All right, and it says line 1 and line 2 are shown on the graph above. Use the graph to answer parts B through F. Okay, so question B says, what is the y-intercept of line 1? So what that means is, what point on the y-axis is line 1 intersecting or crossing over this y-axis here? And we can see for me, my line 1 is crossing over at this positive number 6. So the y-intercept of my line 1 is 6, or I can say B is equal to 6 because in the slope-intercept form of my equation that I'm going to use later on, we're talking about the y-intercept. Now, question C for me, what's the y-intercept of line 2? So I'm going to go back and show you my line 2. Here's my line 2, and it's crossing my y-axis right here at positive 3. So for me, my y-intercept for my line 2 is 3, or I can say that my B for that slope-intercept form of the equation is 3. All right, so now let's go on to question D. For me, my D says, and this is what yours says, write a system of linear equations representing line 1 and line 2. All right, so we need two things to be able to write this equation. First, we need the slope for each line, and then secondly, I need the y-intercept for both lines. So I've got this second part. I've identified my y-intercept for line 1 and 2 in my previous questions. So I'm just going to remind you then how we find slope. So remember your slope formula, okay, is going to be the y sub 2 minus the y sub 1 over the x sub 2 minus x sub 1. And we want to put our final answer in this form here, y equal mx plus b. So we've got the b's for both equations from the previous problems on question B and C. So I'm going to find my slope now for line 1. So once again, here's my formula, right, that I just mentioned. My slope formula is right here. And I've just identified point 1 and point 2. Now look, I want you to use this little tip here I'm giving you. You can see my point 1 I labeled as 7, 0. Now how did I get that? If you look back at my graph, the 7, 0 is line 1. That's right where it's crossing the x-axis. So that's my x-intercept, and that's a nice easy point for me. Now I already have my y-intercept from my previous answer, but I'll show it to you on the graph again. So on the graph, line 1 is crossing right there at 6. So remember, if I'm going to identify that as an ordered pair, right, I start at the origin, so my x-coordinate is 0. So that point is an ordered pair is 0, 6. All right, so that's really nice because now I've got two really easy points that I can use for my slope formula. So when I sub in here, right, for y sub 2, I'm going to go over here to point 2, the y value is 6, sub that in, minus y sub 1, so I go to this point, the y value is 0. Then for my denominator, right, I'm going to go to x sub 2, that's 0.2, the value in the x position is 0, minus x sub 1, so I go to 0.1, and the value there is 7. So now when I subtract, in the numerator, 6 minus 0 is 6, 0 minus 7 is negative 7. So there's my slope for my line 1. So when I sub into this equation, right, I've got the y equal mx plus b. I replace the m with the negative 6/7 from here. I replace the b from my previous problem, which was 6. So here's my equation for my first line, y equal negative 6/7 x plus 6. Now for my line 2, I'm going to do something real similar. All right, there's the slope-intercept form. I know that my y-intercept is b from my previous problem. Now, here's my slope formula, and I'm going to show you my graph again because I want you to see what I'm doing for point 1 and point 2. I'm using the x-intercept again and the y-intercept. So if you go back here, look at my graph here and look at my line 2. It's crossing the x-axis right there. So that coordinate is negative 4 for my x coordinate, y is 0. Now I already had the y-intercept 0, 3. So I want you to do that on your problem too. On your graph, you're going to be able to identify your x-intercept and your y-intercept. So there they are. Now I'm subbing into my slope formula. So y sub 2, I go to 0.2. The y value is 3 minus y sub 1. Go to 0.1. The y value is 0. For the denominator, x sub 2, go to 0.2. The x value is 0 minus y sub 1, which is negative 4. Now you be careful here, right? Numerator is no big deal. 3 minus 0 is 3. But in the denominator, when you have those two negative signs, that's going to turn that into an addition, right? A plus sign. So the denominator becomes 0 plus 4, which is 4. So there's my slope, 3 over 4. Now, when I sub into this form, y equal mx plus b, I replace my m with the 3/4 and replace my b with the 3. All right, so I've got my second equation now, so I'm good there. All right, now we're going on to part E. And part E says estimate what I think the solution is based on what the graph looks like. So when I go back and look at my graph, I'm trying to look at where the lines cross and intersect at, and that is right there. So I'm estimating about what I think my x-coordinate is, and then I'm going to estimate what I think my y-coordinate is. So when I start the origin, I'm going to go along the x-axis so I'm directly underneath it, right? And then, like if you guys on your graph, you're going to have the graph paper, then I'm going to go straight up till I hit that line, and then I'm going to go over to the y-axis. So look, this is an estimate on my part. So I think I'm about right at 2, x was 2, and that's my estimate. And I think I went up to a little bit past 4, maybe 4 1/4. All right, so that's what I'm estimating, all right? Now remember, an estimate doesn't mean that's correct, it's about what I think the solution is. Now to find out if I'm right, on part F, it says solve the system algebraically, and this is what you guys are gonna have to do. And algebraically means we have to use either the substitution method or the elimination method. All right, now here's my two equations that I've already identified for you from part D. Y equal negative 6/7 x plus 6, and there's my second one, y equal 3/4 x plus 3. All right, now since both of these equations are written in slope-intercept form, substitution is going to be the easiest method because I know what the y variable is on both of them. So I'm going to take this part here in the second equation, the positive 3/4 x plus 3, and I'm going to sub it into my first equation for y. So when I do that, it looks like this down here, right? When I take this and bring it and sub it in for y, I'm going to get this right here, 3/4 x plus 3 instead of y equal the negative 6/7 x plus 6. Now when I solve this, guys, this is going to get dicey, right? Because I got fractions. So I'm trying to solve for x. I have an x variable on both sides. I don't want that, and you guys know that. So I'm going to eliminate the smaller variable, which is my negative 6/7 x. The opposite of that is positive 6/7 x. So I add that to both sides. On the right side, it's eliminated. All I got left is a 6. On the left side, it gets dicey because now I've got two fractions, different denominators. My common denominator for 4 and 7 is 28. So when I rename this first fraction, 4 goes into 28 7 times. So I multiply the numerator 3 by 7 and get 21. So this fraction becomes 21 over 28x. On my second fraction, 7 goes into 28 4 times. So I've got to multiply this numerator by 4. 6 times 4 is 24. Over 28x, and then I still have that plus 3. Now, since I have a common denominator, I can add the numerators. 21 plus 24 is 45 over 28x. Now I'm going to solve this for x, so I'm going to get rid of this positive 3. The opposite's a minus 3. The 3's are eliminated. On the right side of the equal sign, 6 minus 3 is 3. So I bring down my 45 over 28x. Now I'm going to finish it over here. So follow with me over here. So I need to get rid of that weird fractional coefficient on the x. Now remember, to do that, we're going to multiply by the reciprocal of that, or the inverse. So to do that, I just take the denominator, put it in the numerator, take the numerator and put it in the denominator. Right, when I do that, right, and multiply, I'm going to get the same number in the numerator, same number in the denominator. That will give me 1. 1 times x is x. On the right side, since I'm multiplying by 28 over 45, I got to multiply the 3 by 28 over 45. Now when I did that, right, 3 goes into 3 once, into 45 15 times. 1 times 28 is 28. 1 times 15 is 15. So that's tough, right? With all those fractions, I had to be real careful. So my x-coordinate there is 28 over 15. Now to find the y-coordinate, I have to pick one of these original equations, right? Either this one or this one, and I'm going to sub this number for x. I'm going to use this one because it's all positive. So I recopied that equation down here for you. There it is, y equals 3/4 x plus 3. Now you see my substitution. I replace the x with the 28 over 15. When I simplify that, denominator here of 4 goes into 28, right? Common factor, 4 divides into 4 ones. 28 divided by 4 is 7, and the 3 and the 15 also have a common factor of 3. 3 divides into 3 once. 15 divided by 3 is 5. So now when I simplify this in the numerator, I have 1 times 7 is 7. 1 times 5 is 5. So I've got 7/5 plus 3. Now when I simplify that, right, 7/5 is like 1 2/5. So now when I add that, I get 4 2/5, right? So now when I solve this algebraically, all right, I get this as my solution. Remember my estimate? For the x-coordinate, I estimated 2. I was a little high. That's all. 15 goes into 20. It's not quite 2. My y-coordinate, I said 4 1/4. It's a little bit more than that. Okay? All right, now, I don't think yours will be that dicey. I think you might have some fractions, but remember, Eureka is big on fractions, so if you do, it's no big deal. Just be careful. All right, now, the last part of it, part G, says, so show that my solution from part E, that weird fractional answer I got, satisfies both equations. So I've got to take this solution, 28 over 15, comma 4 2/5. I've got to sub that in for x and that in for y in both these equations. So here we go. On this first one, I replace the y with 4 2/5. I replace the x with 28 over 15. So on this right side, I'm going to simplify. And again, I have some common factors on the 7 and the 28. 7 divides into 7 once, into 28 4 times. Then for 6 and 15, I've got a common factor of 3. 3 goes into the 6 2 and into the 15 5 times. So when I multiply numerator, negative 2 times 4 is negative 8. 1 times 5 is 5. Now I've got to bring down that plus 6. Now, I'm going to change the 6 into a fraction that's got a denominator of 5 so I can combine those. So 6 technically is the same as saying 6 over 1, so I write that as 5. So multiply 6 times 5, I get 30 over 5. Now I can combine those. Negative 8 and 30 is 22 over 5. On the left side, all I'm doing is just continue to bring down that number. There's no computation to do on the left side. So when I get down to 4 2/5 equal 22 over 5, I know I've got it, right? Because 5 goes into 22 4 times, remainder 2. So it checks here. So that weird solution, 28 over 15, comma 4 2/5, it works in my first equation. Now I've got to try it in the second one. So here's my second equation. So I'm going to replace the y again with the 4 2/5 equal 3/4, replace the x with the 28 over 15. And again, I'm going to simplify it for you now. 4 and 28 have the common factor of 4. 4 divided by 4 is 1. You see that little 1. 28 divided by 4 is 7. 3 and 15 have the common factor of 3. 3 divided by 3 is 1. 15 divided by 3 is 5. So now when I multiply, numerator 1 times 7 is how I got the 7. Denominator 1 times 5 is how I get that. I'm just bringing that plus 3 along. Now the 7 over 5 and the 3, I'm going to combine those. I'm going to do the same thing with the 3. I'm going to rename it as a fraction with the denominator of 5. 3 is the same as 3 over 1. So when I change that, right, 1 times 5 is 5, so I got to multiply this by 5, and that's how I got the 15. You can see that 15 over 5 would simplify to 3. Now I combine the numerators. 7 plus 15 is 22, and 22 over 5 is 4 2/5, so it checks on this one also. So when you guys get done with checking yours, you should get a true statement with both equations. And don't worry, guys, I think if you have fractions, they're not going to be quite as dicey as mine. In fact, you might even have whole numbers, but that's how you do that whole 7. It's really involved. There's a lot of parts to it. All right, so feel free to send me an email if you have additional questions about your number 7. Thanks, guys. Have a good one.